All right, here we go. Last one. Unit 2, trigonometry, page 4, section 2.4. All right, so using those reference angles to find the missing angles. So let's see here. What do we got? Use the special right triangles to solve each trig equation, making sure to use diagrams to help you draw your two triangles in the correct quadrants. All right, we are going to be relying on our calculator very heavily for this section here. So let's think about this. Before we kind of move on, before we do this section, let's review. We have quadrant 1, 2, 3, and 4. All right, so back in 2.3, we kind of had this acronym. It was all students take calculus. All right, so what this meant was all 6 trig functions are positive in the first quadrant. All right, the only ones that are positive in the second quadrant are sine and cosecant. Everything else is negative. Right? In the third quadrant, we have the tangent and the cotangent. Those are the only two that are positive there. And then in the fourth quadrant, cosine and secant. Those are the only two that are positive there. Everything else is a negative. So we're going to be using this quite a bit. So in fact, I'm just going to write this at the top. We know all students take calculus. All right. So first things first, this 2, square root of 2, this is a positive fraction. All right. So what that means is this cosine of theta needs to be positive. Where is cosine positive? Well, if you look at our kind of key up here, cosine is positive in the first quadrant and the fourth quadrant. So we need to make 2 triangles here. So the first one is going to look like this. All right. So we know the cosine goes with the adjacent over the hypotenuse. All right. So the adjacent here is square root of 2. And the hypotenuse is 2. All right. Now we also need the lower one. All right. We have this triangle down here, which again, the adjacent is the square root of 2, and the hypotenuse is also 2. To solve each one, we are trying to solve for theta here. Now, just a really easy way to do this. On your calculator, we are looking for theta. So here's what we can do. I'm going to type in the inverse cosine. So I'm going to say the inverse cosine of the square root of 2 over 2. That gives me theta. All right. So we have the inverse cosine of the square root of 2 divided by 2. All right. Now, what is that going to be? That is 45. So we know theta equals 45. All right. This right here is a 45-degree angle. Now, keep in mind, that's a reference angle. So what that means is that this angle down here is also a 45-degree angle. All right. We want 2 thetas here. So what we're going to do is just think about how can we get over here? What is that angle measure here? All right. So that angle is just 360 minus 45. Right, and that gives us 315. All right, so the other angle here is equal to 315. There are 2 angles that are associated with the cosine of theta equaling to square root of 2. And let's just do that. So let's type in the cosine of 45. Gives us that 2 square root of 2. This number right here, this 0.707 is the square root of 2 over 2. Right? If I just type that in, square root of 2 divided by 2, that's going to give me that same decimal, right? So the cosine of 45 equals that decimal. Let's do it again with the 315. So the cosine of 315 here is that same decimal. So these are the two answers that kind of go with this one. Right? So those are the two values of theta. Now on this next one, the cosecant of theta, keep in mind, this is a negative. This is a negative value. So what I'm going to do is I'm going to call this negative 2 over 1. All right. So if we look up top, cosecant goes with the sign. So since it's negative, it has to be in quadrants 3 and quadrants 4, because that is where sine is negative. All right. So here's one triangle. All right. So think, what does cosecant go with? Cosecant goes with the hypotenuse over the opposite. Right. So we know there's going to be another one somewhere over here. All right, so we have a 2, and then we have another -1. Now, the way we type this one into our calculator is going to be a little bit different, right? Because there is no cosecant button on our calculator here. So if we look at, we know the cosecant of theta, it was -2 over 1. Here's what we're going to do. I'm going to call this, in fact, I'm just going to call it -2. I'm going to say this is equal to 1 over the sine of theta, right? Because that's the reciprocal. 1 over sine of theta equals -2. And what we have to do here is we have to solve this for the sine of theta. So we're going to multiply both sides of our equation by the sine of theta. And we're going to have 1 equals -2 times the sine of theta. All right. And then last step, we're going to have 1 over -2. Just divide that -2 on both sides. And we have the sine of theta equals -1/2. All right, so when we go to type this into our calculator, I'm not going to do the cosecant of theta equals -2. Instead, I'm going to do the sine of theta here, right? So I need to type in on my calculator the inverse sine of 1 over -2, and that's going to spit out one of my theta values here. 1 divided by -2, and that gives me an angle of -30. Right? So let's keep in mind, we have a 30-degree angle. That is our reference angle, because we said reference angles are always positive. All right. So what we need to do is we need to figure out these two angles. All right. So the first one here, that's 180 plus 30, which gives us 210. Right, so theta equals 210. All right. And then the next one, is this angle right here. It's not a full circle, so this is 360 minus 30. This gives us 330. All right, so theta also equals 330. Those are going to be the two answers for this one. Right, and again, we type in our calculator. If I type in 1 over sine, right, because cosecant is 1 over sine of 210, that should spit out a -2, which it does. If I type in 1 over the sine of 330, that also spits out a -2. Okay. So keep on keeping on here. The tangent of theta, so we know it's negative. All right, so tangent is negative in quadrant 2. and quadrant 4. All right, and we need to find these values here. All right, tangent. Tangent goes with the opposite and the adjacent. So we have a 1 and we have a square root of 3. And we have to think about which one, where should that negative go? The negative needs to go with the square root of 3 because it's going backwards on the x-axis. All right. And then on the other one, again, the opposite, we're going to have 1 opposite over adjacent, 1 over the square root of 3. But on this one, the negative has to go with the 1 because it's going down 1 space here. Right, so what we need to do is figure out those values. And again, the calculator always gives us 1. It's just our job to find the other. So we're going to have to do the inverse tangent to kind of reduce it, or to figure out what theta is. So I'm going to say -1 divided by the square root of 3. And that gives me one of those angles. Right, which is -30. So it gives us a -30. Just keep in mind that means that this angle down here, we have a 30-degree reference angle. Right, that is not, let's try to find our positive answers here. So this angle right here is 180 minus 30, so that's going to be 150. And then the second one is going to be 30 shy of 360. 360 minus 30 gives us 330. All right, so our two values of theta, our two angle measures here, are 150 and 330. And there we have it. And so that's what we solve for tangent. All right, so we got one more. Sine, it's positive. All right, so that should help us. That should help us identify what quadrants it's in. Well, sine is positive in quadrant 1. And sine is positive in, it should have been blue. Sine is positive in quadrant 2. All right, so if we think sine goes with the opposite and the hypotenuse. So we have the square root of 3, square root of 3, and then 2. And then over here, we also have the square root of 3 and 2. All right, so if you remember your 30, 60, 90 triangles and your 45, 45, 90 triangles, you might have noticed that this is going to be a 1 and this is going to be a -1. And that is useful because we don't even need the calculator for this one because we know that this is a 60-degree reference angle. Both of these are 60-degree angles. So what that means is that this first one is 60 degrees, all right? And the blue one is 180 minus 60 degrees, or 120, right? So if you do remember those, 30, 60, 90, 45, 45, 90 triangles, this one will save you a lot of time. You don't have to type it into your calculator. We could, right? We could do the inverse sine of the square root of 3 divided by 2, right? And there's that 60 degrees. But, just knowing those triangles saves us a little bit of time. All right, so theta equals 60 and 120. All right, and that one's done. All right, now on this one, we need our calculators. All right, there's no getting around this. So the inverse tangent now of 3.07768, punch that in. It's going to give you a decimal. I'm just going to round this up, all right? So it's 71.999. I'm going to call that 72 degrees. All right, so that is a 72-degree angle right here. All right, that's what a 72-degree angle looks like. Keep in mind, this is a positive number, so where else is the tangent positive? Tangent's positive down in the third quadrant, so this is also 72-degree angle. All right, so the first theta is just the 72 straight up, and then the second one is going to be 180 plus 72, which I think that's 252. All right, so in this problem, theta equals 72 and theta equals 252. All right, so these aren't, exact values, kind of how we had on the first three. But again, type them in, tangent of 252. It should spit out that kind of ugly decimal. We have that 3.07768. Right? So on the next one, the cosine. The cosine of theta, I have no clue what that is, so go ahead and inverse it. We have negative 0.35836. All right, that gives us 100. I'm going to call that 111. All right, so that is a 111 degree angle. So this right here is 111, but I don't care about the 111. I care about the reference angle. So what is it going to take to get us to 180? That is going to be 69. All right. Now, keep in mind, this is a negative value, and we know cosine is negative in the second quadrant. All right, so that checks out. All right, but where else is cosine negative? We have two triangles that we have to make. All right, so we made the first one. Cosine is also negative in the third quadrant. Right, so this reference angle down here is also 69 degrees. All right, so the angle that we're looking for is 180 plus 69, which is something. 180 plus 69 is 249. 249. All right, so theta, our two answers for theta were 111 and 249. So let's just double check it. Cosine of 111. It's that same decimal that we got. And then the cosine of 249 is, the same thing. So that one's correct. All right, now, last one here. Cosecant of, this one's going to require a little bit more work here. So we have cosecant, I'm going to need a new page. Cosecant of theta equals 1.83607. All right. Because we can't type in the cosecant in our calculator, we're going to have to do what we did kind of upstairs on, I think it was question number 3 on this page. 1 over the sine of theta equals, is that a positive or a negative? It's positive. All right. Equals 1.83607. Go ahead and solve this for the sine of theta. All right, so we're going to have 1 equals 1.83607 times the sine of theta. Now we need the sine of theta by itself, so divide both sides by 1.83607, and that equals the sine of theta. Now, we need to inverse this, right, to give us, theta. So we have the inverse sine of this fraction now. So it's 1 divided by 1.83607. That's going to give us an angle of 33 degrees. All right, so theta equals 33 degrees. That's one of our answers. So I'm just going to go ahead and write that one in. All right. We have a 33 degree angle right here. And remember, this is positive. All right. Cosecant goes with sine. Where else is sine positive? Sine is positive in the second quadrant. All right, so here's our second value, and we need to figure out, hey, what is this angle right here? And that is 180 minus 33, which gives us 147. All right, so theta equals 33, and theta equals 147. So just for the sake of completion, to type those in, we can say 1 divided by the sine 33 should be that number, which it is, right? And 1 divided by the sine of 147, there it is, all right? So there we have it. That was section 2.4 in a nutshell. That was page 4 on your Unit 2 test. And there's your Unit 2 test review in its entirety. All right, so good luck.